Hi everyone and welcome to part B of week 11 lecture for 2:30 on the theories of motor control. Now here we're starting on slide number 10, and so we're focusing on the slide that's entitled Two Theories of Motor Control. Now in this particular section of the lecture we're going to focus on motor programs based theory. So in this particular slide here, so slide 10 is showing us that there's two main theories of motor control that we focus on in this particular unit. We look at what's called motor programs based theory and what's called dynamical systems theory. Now let's go for motor programs theory first because that's going to be the focus of the next 10 slides. Motor programs theory is basically a memory-based representation of a motor program within the brain, and it's a very linear approach to learning, meaning learning occurs in some nice sort of linear sequences from one to the next. Very different from what we call dynamical systems theory, which we'll talk about in part C. So if we go to slide number 11, let's talk a little bit more about the motor programs based theory. Like I said before, it's like a memory representation perspective, and it's a hierarchical system, meaning all the part of the brain up here, there's a motor program here for any movement that we want to do. We just have to access that, remember that motor program, retrieve it from our long-term memory, and then be able to implement it based on two different components. And those components are called invariant features and parameters, which I'll go into detail a bit more later. But the signature of, looking at motor programs theory is what's called a generalized motor program. So according to motor programs based theory, that any skill that we want to perform, even if we haven't done it before, like it might be ice skating or rock climbing or catching a ball or throwing a ball, kicking, whatever it might be, that we actually have a motor program already inbuilt for that particular skill inbuilt in our brain. Even if we haven't practiced that skill before, what happens is there's a program for it, and we have to access that program, and to get better at that particular skill, we practice, therefore increasing our features, our parameters, but also too, each of those skills has what's called an invariant characteristic. I'm going to explain what invariant characteristics are, but they're basically the signature of this particular program because they dictate how each of the program actually is performed. So if we have a look at slide number 12, it's going to focus a little bit on the invariant features of the skill. And the invariant features that we mainly look at are what's called force and timing. So according to motor programs based theory, right, if we looked at the tennis serve for an example, and let's break the tennis serve up into 4 parts, and let's go, let's say they're equal parts just for now, and they might be the ball toss. So ball toss is part 1, part 2 might be racket preparation, part 3 might be towards contact, and 4 would be contact and follow through. So that would be 4 parts. Now say for example, a tennis serve took us 1 second to complete in total. Well, according to motor programs theory, let's break up into the 4 bits, and let's just pretend, right, for argument's sake, that we do the tennis serve, we spend 250 milliseconds in each of those 4 different components. So ball toss, 250, 250 racket preparation, contact 250, and follow through is another 250. Now, if we then did the tennis serve faster or slower, according to motor programs theory, the percent of time spent in each of those phases would remain the same. In other words, they don't vary, they're invariant. So in other words, if it took us 2 seconds to do the tennis serve, instead of being 250 milliseconds in each component, in theory we're saying we'd spend 500 milliseconds in each component. Even if we did the tennis serve really fast, the amount of time spent in each of those different phases would remain the same. And that tells us, according to motor programs based theory, that that's evidence that each of these programs for serving or catching or running or walking has their own generalized motor program, and they have relatively invariant features, meaning timing and force of the movement are going to be the same for that movement regardless of how fast or slow or how hard or how soft we perform the movement. So that's a really important characteristics of motor programs based theory is number 1 is the invariant features, and that's the identity signature of a generalized motor program. And I'll show another example about walking and running in a sec, and that will just give you a bit more insight. Now, parameters are characteristics that can vary from one performance of the skill to another. And as we increase practice, we increase the size of the parameter. So for example, if we said we had a motor program for kicking a soccer ball, as we practice over different distances like 5, 10, 20, 30 metres or 40 metre kicks or passing or shooting, all these number of different skills that we perform, by practicing we're increasing our parameters. And therefore, according to motor program-based theorists, that means the program gets stronger and it gets more stable. So practice is the parameters increase in different requirements or environments of the skill, and the signature of the skill is what's called the invariant features. So if we go to slide numbers 13 and 14, number 13 I've already gone through to explain that. So it actually goes through words, invariant features and the actual parameters of the skill. But if we go to slide number 14, we're going to look at some really good evidence back in the 80s from Shapiro and colleagues, and they actually try to describe the differences between walking and running, and that was one of their main reasons for really saying that we have different motor programs for different skills. So they looked at this, they looked at the different components of the walking and running action, and what they got people to do is they got people to walk on a treadmill at different speeds between 3 and 12 kilometers an hour. And what they found was the relative time spent in each of the phases for walking was very similar, almost the same, so that was evidence of a motor program. But what they found when it came to running, as soon as there was a certain speed, which was different for everyone, they changed from walking to running, the different time spent in each of those phases was seen for running than for walking. In other words, the invariant features for the walking program, the time spent in each of the phases, was different than when they started to run. So that was evidence there's a motor program for walking and a motor program for running, because they spent different proportions of time in each of the different 4 phases or step cycle phases that they introduced. So this was really strong evidence that there was a different motor program for running and for walking, therefore evidence for the motor programs based theory, and definitely evidence for these invariant features of the skill, which can be seen in that particular slide. Now here is just a picture, a diagram explaining what I've said in relation to the tennis serve, the walking action and the running action. But we can see here whether something's performed at normal speed or fast or slower speed, the time spent in each of those phases of movement will be the same percentage of the total time. In other words, this slide here is just showing you the visual representation of the invariant features of a skill according to motor programs based theory. So that's slide number 15. So if we go to slide number 16 now, we hear a thing called schema theory. So schema theory is just another example of a motor programs based theory, and it came from Smith in the 1970s. So schema is a set of rules that provides a basis for a decision, and it's all to do with motor programs based theory. So Smith's schema theory is a formal theory of how the generalized motor program operates to control coordinated movement. So we go to slide number 17 now. That's just a picture, a diagram showing us the components of schema theory. We have the movement outcome, we have the movement parameter, which increases with practice, the sensory consequences of the movement, and the initial conditions of the environment, so the actual environment itself. Then if we skip through to slide number 18, what we found though is there were some issues with the generalized motor program theory and Smith's schemas theory. And what it came down to is this whole idea of a novelty problem and a storage problem, and what's called the specificity of learning hypothesis, which we went through in weeks number 6 and 7 for this particular unit. Now the novelty problem just says to us that, well, that sounds really great and all well and good, we've got a motor program for each particular skill, but still doesn't really explain how we're actually able to perform a skill or have a motor program which we haven't done before. So that novelty means new skill. How can we have an inbuilt motor program for something we haven't done before? So there was a question mark over that. There's also a question mark on storage. Now we know that the long-term memory is limited, unlimited in its capacity, but there's still this notion of how can we possibly have all these places for storing all these motor programs too. So there's a question mark over that. And there's also the specificity of learning hypothesis. So it really didn't take into account the person, the task and the environment, and putting all 3 of those together in relation to learning. So there's also always, although we've introduced some ideas of the generalized motor program and the schema theory from Smith, there were some issues in it that are outlined in slide number 18. So therefore that takes us up to the motor programs based theory. Now we could go into a lot more depth and a lot more history on it, but for where you are in your point in time for this particular unit, the focus just needs to be that you need to understand what a generalized motor program is, what are the invariant features, and what are the parameters and how do they define how, according to Mater program space theorists, that movement actually occurs. And that's the end of part B of this particular lecture. So part C will be on dynamical systems theory, and we'll introduce that next.